I showed up at Washington University on January 1st, 1974, and have been here ever since, and have been involved in pretty much all the Mars missions, both U.S. and international, in addition to being a participant in one mission around Venus. So I'm the deputy principal investigator for the Opportunity Rover mission. That's the rover that's way out of warranty. It landed in January 2004, and it was supposed to last maybe 90 days or 180 days. We're just about to plan the 4,000th day on the red planet. And it was supposed to drive maybe 600 meters, and we just finished 42,195 meters, which is a marathon, 26 miles.
Just before Opportunity completed that 26-mile marathon, Dr. Raymond Arvidson and his Washington University team found a clay-rich target just beyond a Martian crater. That gave Opportunity's mission team the idea of selecting the Spirit of St. Louis theme for the crater. So the crater is now appropriately named after the famous aircraft Spirit of St. Louis, known for the first solo nonstop flight across the Atlantic. Appropriate, as Opportunity is making history, crossing a planet of its own when no one imagined it could.
It's way out of warranty. Shouldn't have gone this far. Should have long ago just stopped and stopped radioing back. But it's just a well-made American vehicle. Just keeps going and going. You know, it's old, it's a little bit arthritic, but we're still producing practically every week some new scientific discoveries. So we entered a valley in an ancient crater rim, and it's chock full of clay minerals, but we haven't even gotten to the clay minerals yet. We can see them from orbit. We haven't driven there yet because we found a crater which is called Spirit of St. Louis crater, and it's named after our town and Lindbergh's airplane because we discovered the site in Washington University in St. Louis, people working on the mission. So Spirit of St. Louis crater has an apron around it that we don't understand. It's chock full of elements that form in hot water in terms of transport and deposition. So we're trying to unravel, what the heck was going on early in time that made all these hot waters come up through this crater rim. And in a few weeks, we'll get that information and then pop over and get to the clay minerals that we discovered from orbit. And in fact, before we do that, within Spirit of St. Louis crater, we have to go to a mound of rocks we don't understand called Lindbergh.
Within the walls of what's only a small space of Washington University, so many big things are happening in this global quest for answers.
It's a period of time that's lost on Earth. So we're going back to the earliest period of geologic time. And it's all about, establishing if the planet was warm and wet, which it was, and whether or not life got started. It's possible we're from Mars, right? Because meteorites coming through our atmosphere, some small fraction of them actually come from Mars. So there's been interplanetary transport of stuff throughout geologic time. And then I'm involved in a couple orbiter missions, a European one and a NASA one. And we archive most of the data for NASA for these planetary missions through what's called the Geosciences node of the Planetary Data System. So we're involved in many aspects of planetary exploration.